All right. Welcome back. Today we are going to continue with our work. We're going to go on to chapter 3. Let's do some notes and let's talk about fractions, mixed numbers, and equivalent fractions. So I'm going to start off my notes with, just like I normally do, my name, the date, which is 10/14, and we're going to call this notes just so we don't get it confused with the other stuff that we're doing. And we are doing 3.1 today. And the title of this chapter is Equivalent Fractions. All right. So I want to go over a couple of terms, just like we normally do, to kind of remind us what we're looking at. And then we're going to talk about converting between mixed numbers and fractions, and most of this should be review, so feel free to go quick if you think you know it, but I do want you to write down everything that I write in my paper. Okay, we have a set that we normally use, and we call that the whole number set. And if I was going to write out the whole numbers, it would go kind of like this. We would have our 0, 1, 2, 3, all the way up for forever. And remember, if I'm denoting a set, which means naming a set, I always use those weird squiggly lines to kind of contain it. And this we would call the whole number set. And it goes from 0 all the way up to, infinity, or whatever the biggest number is, which, there isn't one. Our fractions, though, describes parts of a whole number. And the easy way to think of that is if we divide them into little circles and kind of draw some lines. So we're going to draw a couple pictures. If I'm going to draw the number 1, and I wanted to draw it in a picture like this, I could make a circle, and I would kind of color in the whole circle. That represents one whole. I have one whole thing. And if I write 1/2, recall that that means that I'm going to take it and I'm going to divide it up into the number that's on the bottom here, and I'm going to color in the number that is on the top. So 1/2 looks like this compared to a whole. And this is kind of the key to our fractions. These can get very big and very small, and both of these numbers in their relationship to each other build fractions. So if we're going to name our little fraction, let's take an easy one like this. We have 1/2. The number that's on the top, we're going to call that one the numerator. And the number on the bottom, we're going to call that, I want to make sure I spell it right, denominator. And the numerators is lets us know how many pieces. How many pieces? Always spell pieces wrong. And the bottom says the size of the pieces. And that's going to let us know all about fractions. Now, we're going to be talking about equivalent fractions. And equivalent is a fancy way to say equal. But we typically use equivalent when we're talking about geometry or shapes, and that's why we use them in fractions, because fractions are really talking about these parts of a whole. Okay? So when we're going to write equivalent fractions, I could write 1/2, and I could draw it just like I did before, and color in half. Now, it might not be perfect, but I can write these as equivalent. So equal to 1/2 is 2/4, because if I draw it in like this, divide it into fourths, color 2 of them in, I have exactly the same amount as I did before. I can do the same again here. I can write 4/8, and again, I'm going to need to draw my circle a little bigger. If I draw it into 8 sections, and I color in 4 of them, 1, 2, 3, 4, again I have equivalent fractions. Now, sure, this one is larger, but it still represents the same amount of the whole, and that's kind of our key here. And these are all equivalent. And we're going to be looking at these equivalents a lot here. Now, when we are writing in fractions, we are always writing them in the simplest form. Because mathematicians like things to be in their simplest form. Because otherwise I could write this number, this half, an infinite number of ways. And that would be very confusing when I'm having a discussion with other mathematicians. So instead we've decided that we are always going to write things as simple as possible. And that way we can easily identify similar ideas from other people. Because if different people all came together, oh no, I think it's this, I think it's 2/4, no, I think it's 4/8, it adds extra time to the discussion, and it's much easier if we just come to an agreement and say 1/2. So our simplest form here is 1/2. And our simplest form, we would define it as there are no longer any numbers that we can divide into the numerator and the denominator. All right, let's take a little bit of a closer look at more of these things. Quick though, the simplest form. If I look at this 4/8, I can quickly notice that I can fit a 2 into both of these things because I can see that they're both even. And if I divide the top and the bottom by the same number, it doesn't change the number, because just like when we were doing before where we divide both sides of an equation or add or subtract, as long as I do it to the top and the bottom, it doesn't change the value. So 4 divided by 2 is 2, and 8 divided by 2 is 4. And then I can check, is this simplest form? Well, I mean, I know it's not, but I can see that again, I can divide the top and bottom by 2. And this again gives me 2 divided by 2 is 1, 4 divided by 2 is 2. Now, if I look at 1 and 2, there's no number I can divide both by to get simpler. The only number that fits into both is 1, and if I divide by 1, it doesn't change the numbers at all. So so this, again, is my simplest form in this case, and that would make it the right answer when I'm writing it down on my questions. All right, so let's take a look at an example of some of the things that we're going to have on our question. I have on our assignment. Sometimes we have another kind of a number, and we have these mixed numbers. I can have a number like this, 3 and 1/3. Now if I was going to draw this out, it would look like this. 1, 2, 3, 4. And these 3 are all filled in because I have 3 holes with a W-H-O-L-E. And this last one, I'll divide into thirds, and I've kind of got my 1/3 colored in. I should have made that bigger. If I was going to divide it into thirds, let me scribble that one out. Actually, now I just ruined the whole thing. I'm going to just do this again. 1, 2, 3, 4. This one is full. This one is full. This one is full. And this one I have into thirds. And I'm going to color this in. So I have 3 and 1/3, but if I want to turn this into what I call an improper fraction, I have a way to do that. And remember, improper fractions have the numerator larger than the denominator. So I could write something like 12 halves would be an example of an improper fraction. So I can say this is larger and that denotes it as an improper fraction. But sometimes I'm going to have to take a mixed number and I'm going to have to turn it into an improper fraction. So here's how I do that. So let's do our little example 1. And we're going to take 3 and 1/3 and we're going to go to improper fraction. So all I do is I take these, and I'm going to take my 3 on the outside, and I need to turn this 3 into thirds. But if I just put a thirds below it, then 3/3 is really just 1, and I've lost my value. So I can't do that. But if I want 3 on the bottom, what I can do is I can write my number again like this. 3 wholes plus 1/3. And I can use the same thing that I use for equivalent fractions to get this to be a 3 on the bottom. So I can do times 3 times 3. So this gives me 3 times 3 is 9/3 plus 1/3. And if you remember how to add fractions, we just add across, but we can only add if the bottoms are the same, if these denominators are the same value. So 9 plus 1 is 10. 3 and 3, I just leave the same, so I have 10/3. So this would be my answer when I'm taking a number and I'm turning it into an improper fraction. Let's do another one. Say I have 6 and 1/5, and I want to go to an improper fraction. Okay, so I have 6 wholes plus 1/5. I can't add these, but if I turn this bottom into a 5, I can. And then I can multiply 1 by 5 to get it, and I have to do the same thing on the top. So now I have 30/5 plus 1/5, which gives me 31/5. Nice. So that would be my answer if I'm converting from from mixed number to improper fraction. Okay, let's look about going back. Example 3. So this time we're going to go backwards. So say, for example, I have 27/5, and I want to go to a mixed number. The way that I want to do this is that I'm going to try to pull out as many wholes as I can. So I can see that there's 27 and 5. So how many 5s can fit into 27? So I can count. Well, I can just tell. I think it's going to be about 5. 5 times 5 is 25. So I can just rewrite this as a separate addition, and I can say it's 25/5 plus 2/5. And 25/5 I can rewrite as 5 because that is a fraction. That is 5 plus 2/5, and I can rewrite this as 5 and 2/5 for my answer. So I kind of go backwards the same way that I came in. Okay? Another way that I can do this, let me get another example. Is that I can look at this and do a little division problem and find the remainder. So for example, say I'm going to do 16/3, and I'm turning this to a mixed number. Well, I can do this. I can do 3 into 16. Okay, how many times does 3 go into 16? 3, 6, 9, 12, 15. Okay, so it goes 5. 3 times 5 is 15. Subtract, I have 1. Now, if I wanted to go decimals, I could. But in this case, I just want to find my remainder. So I have 5 remainder 1. So that's going to tell me it fits in 5 times. So I can just write my 5, because that was my total, and my remainder becomes my numerator of my fraction. My denominator stays the same because it's still thirds. So I can use either of these ways to go from an improper fraction to a mixed number. Okay, I have just 2 more examples I want to go over, and these 2 are about equivalent fractions. Example 5. So say I'm going to get a fraction, and I need to write 3 equivalent fractions of it. So write 3. Let's see, I'm going to take 3/5 is my original fraction. And I need to write 3 equivalent fractions. So I'm going to take 3/5 and I'm going to multiply both sides by 2. And that's going to give me 6/10. Awesome. Here's 1. Okay, now I'm going to do it again. And I'm going to multiply both sides by 4. 3 times 4 is 12. 5 times 4 is 20. Nice. And let's do one more. 3/5. And let's do times 10. I can really do times anything as long as it's the same. 3 times 10 is 30. 5 times 10 is 50. Nice. I have 3 equivalent fractions for 3/5. All of these are equal. If I drew them out, they'd be the same number. Let's do one more. Example 6. Make sure that I'm on the right page. And let's take 12/3. And this is an improper fraction. I can definitely create equivalent fractions for it. So let's take 12/3. Let's multiply by 2. Okay, 24/6. There's 1. Take my 12/3 times 10. 120/30. Nice. And lastly, let's do 12/3. Let's multiply by 100. Now we have 120 over, sorry, no, I have 1,200 over 300. There we go. 3 equivalent fractions for my answer. So this is kind of going to be a just reminder of how fractions work. Go ahead and go on to the homework, and good luck. Thank you.